For this problem, we're going to be writing the polynomial function of least degree that has the following zeros. So the key thing to understand here is the relationship between zeros and the equation. And so if we start with this, we know that one of our zeros is -5. So what that means is if -5 is a zero, it has to have come from the factor x minus 5, because -5 plus 5 would equal 0. So this is the factor that relates to the -5. Now, if we have a multiplicity of 2, that means that we had 2 of these factors, which could also be written as one of the factors squared. Now, since we're going to have to potentially multiply this out in the end, I'm going to leave it as 2 groups. Okay, the other zero we have is -3/5. So that would come from the factor x plus 3/5. Basically, you're going to put the opposite sign in the factor, because if the signs are opposite, they would cancel and become 0. So this here would be a polynomial function of least degree that has those zeros. If we were told to put this in standard form, then we would multiply these out together. We could multiply these together and we get an x squared plus 5x plus 5x plus 25, which those can combine. So x squared plus 10x plus 25, then multiply that by our final group. I didn't need to put 0 there, I could put y. So once we're here, then we'd multiply each of these to each of those, and we'd end up with some kind of x cubed plus whatnot. Since these directions don't explicitly say to write it in standard form, you wouldn't have to do that, but that is the process you would take to write that in standard form.